pause. Oh, did you hear that?
Yeah.
So welcome everybody to our first formal lecture. Well, we did have the other week, 2 weeks ago, our public lecture, but this is our first online lecture. We would like it to be in person, but sadly we don't have the opportunity quite yet. Maybe after Christmas, watch this space. This evening, I'll hand over to Graham in a minute to introduce our speaker for this evening. There actually isn't much in the way of any sort of notices or housekeeping with regards to the society to let you know about, other than the lectures have started and do keep coming to them, keep coming every other week. So we've got a full lecture program this year. So that's all I have to say. So I'm going to hand straight over to Graham so we can get on with our lecture for this evening.
Okay, that's great. Thank you, Tom. Well, welcome everyone to the start of a new session. It's a shame we're still not able to meet in the Granite Institute, but hopefully things will change as the session goes on. There's not always a theme to the lecture program as a whole, but I did have one eye on COP26 coming up in our autumn-winter session. So the first few lectures are not trying to grab the limelight from COP26, but at least trying to be sort of on theme a little bit. And so I hope everybody enjoys what we've got lined up for you as the session goes on. For the first of our lectures, for the opening lecture, I'm very pleased to be able to welcome Dr. Louis Howell. Louis certainly qualifies in my book as a young researcher, so it is nice to have a diverse group of speakers coming and talking to the society. So it's very nice to welcome Louis. Louis graduated from Keele University. I'm just glancing to my notes at the side here, in 2015, and then he went off to Aberdeen to do the Integrated Petroleum Geoscience Masters at Aberdeen, but the call of Keele was obviously too strong. He came back to join the Basin Dynamics research group at Keele to carry out his PhD research, and it's some of that research we're going to hear about tonight. Louis completed that PhD earlier this year, and in the closing stages of that, I suppose we could say, he spent some time with Cairn Energy on a placement, a secondment, as he was finishing off and waiting for the external examination of his PhD. And that obviously went very successfully, because subsequently to completing his PhD and defending that very successfully, Louis is now, as you see there, a geoscientist with Cairn Energy and working here in Edinburgh. I say here, but in the same place as the society is based, I suppose we could say. So in his PhD, he looked at really the structural and geodynamic processes that have controlled the evolution of Carboniferous basin systems all over the north of England and into the Midland Valley of Scotland. And Louis and I had many conversations. I was kind of attached to his supervisory team. We had many conversations about repurposing all of the national data sets that we have that relate to Carboniferous data, and how those might be used in the future, and what we can learn from all of that data, some of which was related to coal mining and so on. So we're going to hear some of those thoughts on what that Carboniferous data, some of it was collected so long ago it might almost be Carboniferous, but it's all about the Carboniferous. And I look forward to hearing what Louis can tell us about, in this case, in this particular case, block and basin style rift basins, and what the Fel Sandstone can tell us about the northern Pennine rift basin. So over to you, Louis. Thank you.
Cheers for that, Graham. And yeah, I said earlier, if I haven't explained anything correctly or satisfactorily, or if you can't hear me, just feel free to shout out and interrupt, and yeah, hopefully we'll get the most out of this. But yeah, I just say, as a PhD student, really, you're blessed with an opportunity to learn loads of new stuff, to work with loads of different people. So Graham, for example, is a structural geologist, but a lot of the people at Cairn, at Kiel rather, I think Andy Mitten, who presented not too long ago, maybe, are more interested in sedimentology, and with this work, I was able to work with all of them, bring in all their ideas, as well as bring in loads of different data, as Graham was alluding to. So yeah, it's quite a multidisciplinary study. So hopefully you'll get at least something out of this. So I'll crack on and explain to you what I mean by this block and basin idea here. So the first study referencing block and basins was published actually exactly 100 years ago this year, in 1921. It was a paper that went by the title of The Rigidity of Northern Yorkshire. And I can't remember the fellow's name, but he noticed that there's these really thick accumulations in the kind of more lower lying regions, such as the Solway Firth, and to the north of the northern Pennines, and upon these kind of highs, or these blocks, you've got these really thin Carboniferous successions, such as it's absent altogether in the Lake District, and along kind of the Ulston block, Ulston, that area, again, you've got a really thin succession. This was kind of developed on quite a bit during the 1960s, when a lot of geoscientists were working in the area. Of course, more recently, there's kind of more impressive data sets out there that people have worked on. But this is kind of classic Northern English geology. So some of the themes I'll be covering include structural geology, geodynamics, so really kind of large regional basin scale structural geology, specifically rift basins. Of course, I'll be talking about the Carboniferous geology in Northern England, which it's been historically important, of course, for coal mining, as the kind of it is the source rock for the southern North Sea gas basin. But there's been several attempts to kind of mine geothermal heat out of the Carboniferous rocks more recently as well. So that ties in with COP26 a little bit, I guess. And some of the data I've drawn upon includes seismic data, gravity data, some geochemical data from just outcrop samples, a lot of numerical modelling, but also loads of the borehole sections, borehole scans, which have been stored by the BGS and other organisations since. So yeah, this is a geological map, of course, just highlighting that Carboniferous geology essentially forms the backbone of Northern England and central Scotland. It's my PhD cover both areas, but I'll be focusing more so just over the border, specifically within this blue unit here, part of which is made up of the Fel Sandstone Formation, which in the region has been important as a water aquifer, but also as a reservoir rock for both geothermal purposes and oil and gas exploration. The northern Pennine Rift Basin formed in response to kind of early Carboniferous lithospheric stretching, or rifting, to give it its more kind of informal name. But what makes the northern Pennines kind of unique and interesting to study and to teach people about is this relationship between these granite intrusions, which I've kind of surrounded in dotted lines. They're the X's there. And these kind of intrabasin highs, or blocks, as I referred to earlier. So, for example, we've got the Ulston block here. It is caused by this this low density granite intrusion called the North Pennine Batholith. That was first hypothesized actually by Martin Bott, then of Durham. based on gravity data. I think about 10 years later, somebody else from Durham funded a drilling campaign, and they actually targeted this and penetrated this granite intrusion about 3 meters above or below where Martin Bott predicted. So that was a pretty breakthrough and impressive back in the day. Just along the border, we've got the Cheviot granite, which actually crops out at surface. That's another high. It's kind of this area around the Cheviot block I'll be looking at with the Fel Sandstone Formation in a sec. You've got further highs and granite intrusions throughout the region. And these also carry on offshore, and this kind of paleogeographic map, if you like, has been reproduced countless number of times in an attempt to aid the exploration of the southern and central North Sea, kind of more so gas basins here. So this is a 2005 publication, which is one of several within that kind of 10-year period where they're summarising loads of data on the North Sea. I mentioned these granite intrusions, and whilst they're not always exposed at surface, they're fairly obvious when you look at regional gravity surveys. So because granites are composed dominantly of quartz and feldspar, which are less dense than a lot of your metamorphic minerals that you see in your slates, like garnet and other minerals, for example, they're effectively more buoyant, and they stick out like a sore thumb on a gravity survey, at least when you don't have much sedimentary cover. So I've just kind of labelled the granite intrusions of Northern England here. So hopefully you can recognise the kind of coastline going down here. You've got Berwick upon Tweed up around there, and Newcastle upon Tyne, I guess, is down here. It's typically these kind of anomalously low gravitational areas are associated with sedimentary basins. So sediment's porous, of course, and that void registers on the gravity surveys. But because effectively, as a consequence of uplift in the last 60 million years or so, when the Atlantic broke up, we've removed a load of sedimentary cover, and we've got a really strong response which reflects basement composition and not sedimentary cover. And you can see this is a kind of depth to basement map, how these highs, the Ulston block being one, correlate really well with these low density granite intrusions. This kind of anomalous shape here is actually a response to the basin fill from the Vale of Eden. So that's your kind of regional framework, if you like. But of course, and this kind of reiterates that point. I forgot this one made it in. So for this top line here, you're seeing the Northumberland Trough. To the left of that section, you've got the Southern Uplands, which is called itself by a few granite intrusions. You then hit the Ulston block here, and this is underpinned by one of those low density granite intrusions. You can actually pick out the top here, very tentatively, albeit. And beyond that, you're into the Staymore Trough, and the kind of going towards the Southern Pennines, if you like. So that's an example of some of the data that was collected in the late 1980s as they were trying to kind of short-lived oil and gas exploration onshore in this part of the world. So that now is your regional framework in place. Which is all well and good knowing that, but it's actually the sediments that were deposited in these basins which are important from, not just oil and gas perspectives, but from geothermal, from drilling for bridges. It's the actual rock deposited within the basin that's important. So I'm going to talk about how that kind of regional framework interplays with one unit deposited during this early Carboniferous rift phase, and that's the Fel Sandstone Formation. So this was deposited pretty much slap bang in the middle of that rifting phase. It crops out around Northern England. It kind of swings around the Cheviot High, if you like, through Alnwick, kind of on the southern margin of the hills that make up the Southern Uplands. And just before it gets to Carlisle, it's then buried beneath Permian sediments, if you like. So typically, and I'm talking mostly around Berwick upon Tweed and kind of northeast Northumberland. It forms this kind of craggy hillside. This is a picture from just probably several kilometres, 2 or 3 kilometres southwest of Berwick upon Tweed. And this fella's farm, who was kind enough to let us go and explore these rocks. Essentially, you get these crags where you've got the more weathering resistant sandstone, and you get these kind of plateaus of steps where you've got the kind of less weathering resistant muds, and together this forms a carboniferous fluvial system. So the muds with the overbank, and the sands were with the channels and kind of accretionary elements, if you like. Typically, with a lot of the work that's been done on the Carboniferous up to centuries ago, these units are named solely on their kind of lithological characteristics, but I have had an attempt amalgamating a load of biostratigraphic and pollen data to kind of put an upper and lower margin in time on this unit, so we know we're kind of comparing like for like when we go down this system. Okay, so that's the kind of background of not just the basin, but the unit itself. And now we're going into some of the work that I and a few colleagues of mine at Kiel managed to get up to. So these are quite small logs, so we'll just zoom in. So we're kind of going now from the northeast down to the southwest and just comparing the sedimentological characteristics in different parts of the basin. So here we're just about near where that picture is actually. So we're penetrating those same units, but just within a, I think there's 100, just under 200 metre borehole section. So you hit the top of the Fel Sandstone succession in this part of the world. I think this was drilled by Northumbria Water many years ago, and you see this change from this one pollen zone, which makes up part of the Sandstone Formation in this part of the world, and you hit these kind of coarse-grained up to gravelly sized sandstone units composed of gravelly cross trough beds and planar cross beds. You're preserving quite a lot of mud in this system, and there's no indication that this mud was deposited in a kind of marine environment, because you're not seeing bioturbation amongst other things, or marine fossils. Instead, there's quite a lot of plant fragments, which could potentially be misleading, particularly in a borehole section. The kind of unit repeats itself every now and again. I think in this part of the world, some BGS geologists have given these units individual names and tried to correlate them across the region. As in this part of the world, this is an important aquifer. It hasn't been buried as deep, and therefore it's not as well cemented. But to summarise, you've got quite a mixed, solely fluvial, quite a mixed, coarse and fine-grained unit here. And this is around Berwick upon Tweed. So your faces are hiding me map, but hopefully that map suggests that as well. Going slightly downstream, so now we're just around Alnwick, hence the name the Alnwick borehole. So this is another borehole succession, slightly shorter, just over 100 meters. So here we've almost eliminated all our mud. Now, typically in fluvial systems, because they're dominantly dispersive, you have a greater sand concentration upstream, and as that fluvial system goes downstream, you're getting less reworking, a more potential to preserve your finer grained elements. However, here that's not quite the case. What you're seeing is a succession made up of almost solely at least fine grained sandstones, up to gravel sized in places. There's a few exceptions here. You can see these muddy bits here, and this one bit here, you're seeing a few signs of marine fossils. So in terms of, if you're interpreting a kind of marine transgression, this would be the area where you'd suggest there's a kind of upper limit to that. There's bits of floodplain in between, but as I mentioned before, this is almost solely sandstone, so you've got a lot of reworking, and a lot of the mud that maybe once would have temporarily been deposited here. That's being washed down system somewhere. So it's starting to build up a little bit of a regional picture, although at this stage it's still quite a confusing one. Going down system still, and this is, well, we should have a map to the right there, but yeah, so this is kind of almost on a similar latitude to Newcastle, right in the middle of the Northumberland Trough. In this region of the world, the Fel Sandstone is buried that bit deeper, so you're hitting the top of it at just under 400 meters below surface. It's marked by, or its top is marked by the presence of one of these quite characteristic limestones, of which there are many in the Carboniferous period. So this is the Kingbridge limestone. And rather than penetrating fluvial facies, here we're actually seeing a lot of marine facies, and I've suggested they're marine because you've got these burrow features, so that means you're more likely to be in a subaqueous condition. You're also seeing marine fossils. I'm not going to pretend to be an expert on fossils, and you're also seeing ripples. So you know there was a current. These could of course been caused by influxes of fluvial material, but at least here it's interpreted that a lot of these currents reflected marine conditions, rather than depositing this system into a vast lake as we perhaps did tens of million years before this unit was deposited. So it's dominantly deltaic, and I'll show you the key here. So these pinks I've interpreted as delta slopes, whereas the finer grained stuff I've interpreted as a kind of pro-delta deposit. So that's just in front of the deltaic system. But this arguably dominantly deltaic system is interrupted by a few pulses of fluvial material. So your classic gravel line trough cross beds that I've described in the previous couple of slides. I'll show you a few pictures in a sec. So perhaps during the middle of these dominantly deltaic times, you're getting pulses of fluvial material, which is outpacing sea level rise. So you're seeing these relative water level fluctuations throughout this period. I'll promise some field photos because I can appreciate looking at logs like that can get a bit tedious. We're not blessed with field exposure in Northern England, so you saw a lot of those images were from boreholes. In fact, all those logs were from boreholes as opposed to outcrop data. But there are bits of exposure. It's weighted heavily towards the more weathering resistant sandstone facies. So you can see here, this is at Bowden Dores, which is a popular kind of rock climbing area. You've got a lot of these kind of amalgamated channel sand stacks. You can kind of interpret some of these kind of fracture lines here as reflecting actually depositional environments. So some of these are lateral accretion elements. If you zoom in on this, you can actually see Graham Leslie posing very helpfully as a scale. So you've got a lot of cross-bedded stuff here, which is really clear to see, but this is interrupted by this kind of structureless mass of sand. This has been interpreted in a fairly classic paper now. I think it was Brian Turner back in the 1980s interpreted this feature as a channel bank collapse feature. So perhaps the margins of a channel once upon a time were getting unstable to the extent where it collapsed under its own weight in a kind of debris flow kind of manner, therefore not preserving much in the way of sedimentary structures. So this is a kind of proximal end of that system, the dominantly fluvial end. You zoom in on these, some kind of ripple laminated trough cross beds. In places, these form some of these weird kind of recumbent cross-bedded features. I'm not going to hazard a guess as to how they formed. Graham might do that. There's been a lot of debate at Keele University over those. Sadly, this is a pretty dreadful field photo. I was trying to get the message across that there's some quite strong indications of lithic material in some of the more gravelly beds. So some of the pinks that perhaps you can barely pick out. These are actually bits of granite from the Cheviot block itself, from the Cheviot granite. Some of the greys, which seem to be, you know, distant, or at least the greys in the image, you can't interpret them for class or mold, perhaps, or moss rather. Some of the greys are actually andesitic class from the Cheviot andesite. Getting even worse in terms of outcrop here, but it is what it is. You can see some of the finer grained units preserved in between some of these coarser grained units that are exposed far much better. So going, this is about as far as you can get down system before the unit's just buried underneath younger stuff. Andy Mitten there is posing with, again, a pretty dreadfully exposed example of some of the delta muds. You've got little carbonate nodules. That's down near Carlisle. So compared to Berwick-upon-Tweed, you are several tens of kilometres down system. When you zoom in, some of these sandstones are quite messy. You're not seeing much in the way of sedimentary structures here. That, we believe, is because you had living organisms at the time just essentially churning that mass of sand up. And you can see a few kind of darker traces in here. That those, we believe, might be burrows, but you know, certainly there's quite a lot going on, although sadly it's not fantastically exposed. So that's what you've got in terms of outcrop. So that kind of supplements that borehole data. And even though the outcrop is fairly poor, you don't need a terrific amount of outcrop to kind of pick up some other scrags of data, such as paleocurrent. So, you know, providing your basin isn't too mashed up and deformed, you know, paleocurrent can give you a good indication of course, which way the sediment was flowing at the time, but also what was the shape, what was the topography of your basin like when this unit was deposited. So this is an exercise quite a few people have done on the Fel Sandstone Formation. Brian Turner himself, I think one of his PhD students back in the day, have produced similar paleocurrent maps. Myself and a colleague of mine, Charlotte Priddy, we actually started off at Berwick-upon-Tweed one day and drove down system using a load of BGS coordinates for Fel Sandstone outcrop. And each place took somewhere between 20 and 60 paleocurrent readings at each outcrop. And you can see from this that to the northeast, as far as the outcrop goes, just to the west of Berwick-upon-Tweed, you've got a dominantly kind of southwest orientated paleocurrent. That's actually interrupted as soon as you kind of force your fluvial system up against the Cheviot block here. So you've got one of these low density granite bodies outcropping right in the middle of this block. There your paleocurrent rotates towards the south east ever so slightly until you get into the kind of Northumberland Basin proper, at which point the kind of paleocurrent disperses out. So your fluvial system's got a lot more space to run out in, and you've also got a much thicker succession in this part of the basin here. So as I alluded to, the outcrop isn't great, but we do have a lot of boreholes. You know, how well the borehole information is recorded varies. Some of these boreholes that made up this kind of overall net sand percentage contribution date back to the late 1800s and were drilled for reasons including coal as a water aquifer. Down here you've got the Newcastle Science Central borehole that was drilled for geothermal, and the rest of these were mostly drilled for oil and gas exploration. But yeah, essentially with each of these boreholes, I've measured the full length of the succession and the amount of that succession, which is sand, and given it a percentage and kind of contoured around that. So around Berwick-upon-Tweed, where I showed you that first log, you've kind of got a variable succession. The contribution of sand to this succession varies from about 80% down to 40%. So you're preserving a lot of mud. You go down system, particularly to Bowden Doors, to Alnwick, that kind of overall sand composition jumps up to 90% around the margins of the Cheviot block. Before, again, you get into the basin proper, you're dispersing your coarse sediment. You've got a lot more room for your mud to be deposited in. It's not being reworked anywhere near as much. And by the time you get beyond Carlisle, you've got up to 14% mud. And beyond the Ulston block here. So I think this is the Seal Sands. I think I'm not too good at my geography around here, but maybe towards Hull, you're almost getting entirely mud and limestone systems. So with limestone, limestones are most happy when you're not depositing much clastic material. So these are quite common in the oil and gas industry, but in terms of predicting general regional trends for like geothermal purposes, or just even understanding a unit and how it might vary across space, these are quite useful. And kind of once you've incorporated all that data, you can start to you build up your regional picture. So I talked to you earlier about the kind of regional basin structure. You've got these intra-basin highs or blocks, which are caused by these low-density granite intrusions, some of which are buried now beneath carboniferous sediment, some of which are outcropping even now today. So to kind of summarise them findings, around Berwick-upon-Tweed, you've got a dominantly fluvial system. It's fairly, well, you're preserving a lot of mud, so you're interpreting that there's not too much reworking. It's fairly unconfined, sorry. When you hit the Cheviot block here, this is a topographic high now. It's likely it was a topographic high then. You're actually confining your fluvial system. You're reworking a lot of your mud. That's disappearing back downstream. As soon as you hit the Northumberland Basin proper, you've got a lot more room for your sediment to kind of grow in, and therefore you're not reworking that sand anywhere near as much. And that's draining ultimately towards the point of most rapid subsidence. That's right up against one of those normal faults, which, well, from seismic data, we believe were growing during the deposition of this unit. I'll just touch upon some of the interpretations I've done around these highs, particularly the Cheviot block. That was based on, way up, there's one more point there. But these were based on geochemical data that I collected along with another one of my colleagues at Keele. That's Adam Jeffries. So yeah, there's a lot of suggestions that there's a contribution from some of these uplifted highs, and some of this geochemical data actually confirms that. So here we're comparing sediment deposited around Berwick-upon-Tweed in the Tweed Basin there, with some of the sediment deposited slightly down system in the Northumberland Trough here. And you can see, whereas the kind of titanium oxide composition stays fairly consistent, doing our kind of basic XRF, X-ray fluorescence analysis, you can see that there's actually a jump, and it's quite a pronounced one across all the samples we took from this part of the basin in overall strontium composition. And that strontium could have come from a Devonian old red sandstone, which is deposited locally in the southern uplands. It could have also come from the Cheviot granite or the Cheviot andesite, which I've kind of plotted on that plot in these various colours here. Likewise, when you kind of well, we took a load of samples from that geothermal borehole that was drilled. Likewise, with that kind of spatial relationship further up system, a lot of the deposits along the flank of the Ulston block here, they're slightly more enriched in rubidium and potassium oxide, for example. There's a lot of overlap, so rather, instead of having two kind of separate systems, you're seeing a lot of mixing here. So yeah, a little bit more data. We had to do a bit more work on that, but it adds a little bit more depth to this kind of regional interpretation, which we've perhaps stopped doing in the UK. We feel I think a lot of geologists speaking to at university, we feel we've done a lot of UK geology already, but by revisiting some of these units, you can come up with new stuff, especially when you incorporate some of the forgotten about data and kind of blend it with some of the newer stuff, which I've shown you here. Again, this is to kind of reiterate those points, but yeah, it's a bit more new data. So it actually measured the components of these sandstone units, kind of point for point. You can see, unsurprisingly, with the sandstone, it's dominantly quartz. But there's a bit of variation you can pick out here as well. You're getting a lot more lithic components in these units deposited along the flank of the Ulston block. So there you go. And we've still got 20 minutes, so I'm going to skip some of the numerical modelling stuff I've done. This is essentially modelling the influence of these granite intrusions. I'll quickly zoom in on that. So to kind of back up the idea of these granite intrusions leading to eyes, me and one of my supervisors ran a few simulations incorporating the granite and not incorporating the granite. So you can see when you do incorporate it, you kind of introduce that bulge, which actually you see in real life. So that's contributing to the uplift of these highs and contributing to the ability of these highs to kind of deflect fluvial systems and also to contribute sediment into the basin. But so that's a kind of schematic representation of that there. But in terms of kind of applying this more directly to some of the themes we're going to be talking about with COP26 coming up so rapidly. Of course, a lot of those skills always apply to the oil and gas industry every day. But you know, a lot of the skills you can also use to apply to problems such as geothermal, which has been there's been a lot of investment in geothermal in Northern England and a lot of unsuccessful investment, sadly. But it's also the skill base and the kind of these sets of data which you can reutilize to combat some of these problems. So we've discussed the numerical modeling very briefly, albeit, and we've discussed kind of understanding these systems on a regional basis and what might be controlling their characteristics and how they vary throughout space. It's this, as well as a company guilty conscience, I guess, that led me to look at geothermal in Northern England. So I'll try and move those. Yeah, I can read my notes. So although these techniques are most widely adopted by the petroleum industry, you know, numerical modelling and regional understanding of these units can lend itself towards geothermal, as I kind of alluded to there. And Northern England is a place where there's been 3 geothermal exploration boreholes. All of these sadly have been unsuccessful, and they've targeted the Fel Sandstone for one, they've targeted fault plains, and they've targeted these granite intrusions because of the kind of heat they produce. And despite that, in terms of understanding our regional geothermal potential as a country, as an island, we're still at a fairly primitive stage. I've kind of shown you some of the kind of temperature to depth maps here across the UK. You can see that these are produced by just contouring around these points, and one of these heat flow maps, which you tend to see in newspapers whenever there's a report on geothermal potential. So I kind of implemented my numerical modelling methodology on this. So yeah, the kind of same heat flow equation you saw contributing to those cross sections previously, I applied this to a kind of 3D block of different rock units. Each rock unit was given a conductivity value and a radiogenic heat production value. And essentially, you simulate this so it takes into account you know, the controls on temperature. And once you've done that, you can start to produce some of these maps. So this is a heat flow map within the top 500 meters of the crust. You can see, as well as the influences of these kind of sedimentary rock units here, you're picking up the extra heat produced by some of these granites buried at depth. You've got a cool area here that correlates with where you've got a thick amount of the coal measures. That's your kind of thermal blanket. You're not getting much heat escaping through there. This is a temperature at 1 kilometre depth map. So you can see where the coal measures here, they're having quite an insulative effect. So they're actually, although the heat flow's low, it's trapping a lot of heat in. The granites, again, have quite a big influence. You can see that here. And you can see it to an extent in the Lake District there. But again, these sort of things tie quite well with that regional understanding. So for geothermal, for example, you need heat, and you need kind of a water flow. Water flows best through sand, and of course, understand the Fel Sandstone Formation is important for those reasons. And some of the numerical modelling techniques, which I've presented rather briefly, I'm afraid, help you predict where there's heat. So the future's bright for geologists, even in this kind of changing landscape. And hopefully Keele University and people studying Edinburgh can contribute more over time. So I hope you've followed that. I'm more than happy to go back to other stuff and answer questions. That was an amalgamation of a few different talks I've done, so I'm afraid it did jump a little bit after that first bit on the Fel Sandstone, but there you go.
That's great, Louis. Thank you very much. A lot of food for thought there. I'm in a moment going to open it up for questions. I did put a message up in the chat box, but if people want to ask questions, you could put them into the chat, and Tom and I will try and keep our eye on that device to see if there are questions appearing. Or if you go to the reactions button at the bottom of your screen, the bottom right of your screen, and put your hand up, we can probably identify you by that method as well. So Louis, I think if you kill your presentation for the moment, if you stop sharing, then we can get as many faces on the screen as we can, and we'll see where the questions are coming from. So first question, any questions for Louis? Tom, I think you had one lined up, but
I did, and he sort of actually answered it, but that's fine because his presentation gave me many questions that I thought of. So I'll get the ball rolling by asking you said that of the sort of pilot borehole and geothermal heat programs in the North of England didn't sort of get off to any good start, but unless I completely missed the point, your heat maps showed that there was quite a lot of good potential in Northern England. So why didn't they get off the ground? Yeah,
well, it's quite a funny story, really. So the first geothermal borehole sunk in Northern England was pretty much sunk slap bang in the middle of that high temperature spot, if you like, and it hit a granite intrusion that was quite heavily fractured. So I mean, at the time it was definitely a success. They had hot water and it was flowing like nobody's business. Unfortunately, in that part of the world, because you're so sparsely populated, there's not too much demand. I think for that example, and there's a paper written in 2007 about this borehole. For that area, they kind of foresaw it being, they could set up some kind of biological, some kind of biodome, but that was 2007. And in 2008, the financial crash hit, and all of a sudden the kind of motivation for making something of that ample heat supply had kind of gone down. So that was, and I think the most recent attempt to harness geothermal energy was near Newcastle, and they were targeting kind of fault systems there, hoping there'd be a load of fluid flow, but they're also targeting the Fel Sandstone. But sadly, at kind of 2 or 3 kilometers depth, whatever it was, that unit had been so cemented that just no fluid flew through it at all. So yeah, it's not easy.
But there are many other places to potentially, drop boreholes and in more populated areas closer to the granites, and so it seems to have potential.
Yeah, I think there's scope for a lot of kind of regional based studies, and we haven't given up on our geothermal potential yet anyway.
I think that's right, Louis. The BGS observatory work in Glasgow is looking at geothermal potential in relation to old mine workings. Where you've looked at coal measures or coal measure geology, are there lessons you think that can still be learned in that coal measure part of the Carboniferous succession? Are there new insights into the way that, I guess, faulting is in the coal measures part of the succession? Is faulting more important than the presence of sandstones? Do you need a fractured medium? How well do we understand the fault architecture in these units?
Well, I mean, as you know, with the coal measures, the big difference between the coal measures in Glasgow and the Fel Sandstone is that you've got all these kind of open voids in the coal measures.
Yeah.
So kind of understanding what they were doing back in the 1800s is as important as some of that. But again, the coal measures hasn't been revisited from a regional understanding for quite several decades now, and that was despite it probably once being the most studied stratigraphic interval in the world, while there's this ample amount of data that the BGS are hosting and plenty of exposure, plenty of studies, I still think that there's good reason to kind of revisit that regional understanding, which I believe you guys are still trying to do. I certainly attempted to during my PhD. And there's people at Kiel who are still trying to do the same.
Anyone else? Any other questions? If I don't see anything in the chat box, if people just want to unmute themselves and raise the voice, Tom and I will try and pick them up. Any other questions?
Don't be shy. There's no such thing as a silly question.
Yeah.
Can I ask another one then?
Go on, Tom.
The types of data that you were getting, that's all available from the BGS? You can just go and download that, apart from the stuff you got yourself, of course.
So BGS are fantastic for borehole data onshore. The seismic data I got from the UK onshore geophysical library, but I believe the BGS have copies of that, a lot of which I think we sadly lost, because speaking to some of the UKOGL guys, they were rescuing like floppy disk out of skips. What else did? Yeah, there's loads, but the BGS is certainly the place to start.
And how are you amalgamating all this data? I mean, because there's lots of different types of data, lots of different ways of presenting that sort of data. I mean, what was your approach?
You just play it, but I mean, I've submitted a paper on this, resubmitted a couple of times, so I'm still playing about with ways of presenting this story. But I think certainly getting a regional framework in place, so testing that with numerical modelling experiments, and then thinking, okay, if that's your regional structure, how's that influencing deposition, and kind of doing it in that order. And then you've answered one question, and you think of two more, and and then you have to stop.
Louis, there's one in the chat here, Deborah.
Okay.
In terms of the heat resource, how much heat are we talking about for these geothermal sources? Enough for a hot shower, Deborah asks, or just enough to grow lettuces? I guess, or other horticultural products, we should say.
No, well, I think we're talking hot shower territory, so that's kind of district heating, I guess. If you're going above 90 degrees centigrade, you can start to power turbines by boiling fluids that are slightly lower gaseous point than water. So not quite that hot, but certainly district heating. And yeah, had that first borehole been somewhere a bit more populated, then I think that would have been properly exploited.
There's another one from Sheila. I'll come to David Graham's question in a minute about the unusual sedimentary structures. But Sheila asks, are Cairn Energy actively looking to develop thermal energy? I guess this must be a question for a lot of companies that have traditionally been involved in oil and gas, hydrocarbons. How much diversification do you now see in companies active in the North Sea, Louis?
Yeah, so I'd say, I'm not going to talk on behalf of the company and the kind of corporate board members and what have you, but since I've started, and I started my internship about this time last year, back then there was a kind of real reluctance as, okay, the Shells and the BPs can go chase, carbon capture and storage and geothermal energy, but that leaves a gap for us to operate here. And even since then, there's been a load of hires under the kind of banner transition energy. So I think this talk of a climate crisis has scared even Cairn, and I think whilst they're not actively looking right now for specific areas of thermal heat, there's people being employed who are looking for these sort of opportunities. So I think you'll see that changing quite quickly. I shouldn't go into corporate stuff. I'd be dreadful at pitching.
Those unusual sedimentary structures that Louis showed in the photograph, those are very intriguing. In examples that I've seen in the US, I think you've probably seen them as well, Louis, they get referred to as rip-back corals, and they're where the very tops of trough cross bed foresets get dragged by presumably a high density flow or a high density current moving across the top of the foresets in the bed below. So there is sort of a soft sediment deformation fabric for the most part. I think that's fair to say, Louis. What I have seen, though, I didn't see at this particular outcrop, but what I have seen, in some cases, the deformation that takes place in the layer that is being dragged, as it were, is actually sufficiently strong to begin to modify the individual grains. And you see grain scale cracking or fracturing along the margins of the grains, and you get a grain alignment, so that some of these folds, because that's essentially what they are, do actually start to develop an axial planar fabric, which is a really good trick, and we don't really understand. I've never seen a publication that explains the physics and the physical mechanics of the process going to that extent. So yes, these are very intriguing structures, but they are for the most part soft sediment deformations. But if you start deforming the grains, they can't really be soft sediment. It has to be at least partially lithified sediment. So they are quite intriguing, certainly. And there's some nice physics that needs to be done and how these materials behave.
Graham, can I just thank you for that and say there are some wonderful examples in the Bewcastle Fells and the Fel Sandstone there to the west, southwest of your area, which is
awesome.
Yeah, some great, all kinds of other things too there. So thank you.
Yeah,
no, I think that's one of them. I'm happy admitting I don't really know.
Are there any other questions coming up? I'm looking around.
I'll ask one anyway. Right.
Oh,
I'm next door to you on the screen.
all right. Hi, Mike. Yes.
Hi, Louis.
Mike.
I know you won't have done much work with coal measures, but in general, I had understood that the non-marine, like most of the bivalve faunas they contain, with sort of singular and other bands in places at the bottom of the coal measures, and then one at the middle Queensley, and then one or two at the top. I noticed in an unpublished diagram that a EGS person has reinterpreted coal measures as being largely estuarine. How do you feel about that?
Did you pick that up, Louis? It was a bit cracky.
Maybe I'm too far away from the microphone, I don't know.
No, I heard that. Estuarine. I'd have had them down as, I mean, there are better sedimentologies at Keel than myself, but I would have had it down as kind of a low energy delta from what I've seen. And I think I've looked at the with yourself, Mike. We've looked around kind of Port Seaton and a few of the lower coal measures outcrops. But yeah, Graham couldn't speak on behalf of the BGS if he likes.
Low energy deltas in lakes or low energy deltas marginal to the sea.
Yeah, well, I guess I'd have to trust the fossil experts.
Well, I've followed up on that and discovered the paper last year, or this year, and they aren't bridging on the bivalves being non-marine.
Okay. Yes.
I'm not an expert on anything like on that, so if the experts aren't doing it because they haven't thought about it.
Yeah, there's still plenty to do on the Carboniferous onshore, eh?
I agree with you there, yeah. I enjoyed the talk.
Thank you. Cheers, Mike.
Louis, Wilf Wrigley in the chat is asking, are the areas of low heat flow on the map indicating there is a very low geothermal gradient near the surface due to low heat generating sources at depth, or due to the low heat transmissivity of the rock types themselves? Yeah,
good. So the heat flow equation is essentially it's the heat difference at two given depths times by the conductivity. So basically it's a combination of them both. But I mean, you saw on that one heat flow map, you've got an area, the kind of Alston block, where you've got the combination of a kind of high heat generating heat source, the granites, but it's also capped by a kind of cover, a kind of blanket, if you like. In terms of harnessing the most heat, you need that combination, the kind of the heat producing unit as well as a blanket to trap in as much as possible, really. So yeah, I don't know if that answers your question perfectly.
So does it mean, Louis, that in terms of good geothermal resources, yeah, in a way, in the shorter term, you could go into areas of granite or fractured granite and just tap into relatively hot rocks near surface? Or in the longer term, is it going to be more beneficial to try and target those areas where there might be preserved heat, blanketed heat, if we can put it in those terms?
Yeah, I mean, with the problem with deep geothermal, and we're talking deep, we're talking greater than a kilometre, really, is that the kind of profit margins are so slim. So, I mean, if you're drilling an oil and gas well, it costs a lot of money, but if it's successful, you make even more money. So it's kind of worth the risk. Where with geothermal, those margins are so small. But you're targeting areas where you're predicting there's going to be high fluid flow, and you're predicting quite a bit of heat. And for those reasons, the coal measures are really important in Northern England, not just because you have these voids, but because they are the ideal blanket. Coal is so insulative compared to sandstone or limestone. You know, that's, you even entrain just a little bit of that in your unit, and you've got the ideal lithological blanket, if you like.
Yeah. So a good high porosity, high permeability sandstone with warm water in it underneath a blanket is really the sort of geology that might be most profitable or lowest risk, if we can put it in those terms. Would that be fair?
Yeah, and yeah, there's plenty of places the coal measures might provide that. But yeah, we need to do the regional work to kind of de-risk this, and even when we've done that, there'll still be an element of risk.
Yeah. I think that's right. I mean, if you think about early coal exploration, where a lot of that was done by driving adits from coal seen at surface, the coal was exposed and then things developed from there. You don't see heat exposed at the surface. So it's always going to be a much greater challenge, as you say, to de-risk things and genuinely explore the subsurface for something which you don't see outcropping anywhere in any. There are no great number of hot springs across the north of England, let's put it that way. Anyway, any more questions? Oh, one more. Deborah again saying the coal may be a good insulator, but haven't we taken an awful lot of it out? That's losing the heat in many areas. Louis?
Yeah, that's true. I mean, we've gone for the thick coal seam, so that there's thin bits that can still act as insulators, and of course there's a kind of basement below which mining coal wasn't profitable. So, you know, if you're talking about those sort of depths, over a kilometre, over, I don't know how deep they used to drill for coal exactly, but you know, if you're going deep enough, it won't have been mined as well.
Yeah.
But of course, where it has been taken away, you've got these, in the case of Glasgow, you've got these big voids where, you know, you've just got a pocket of warm water.
Yeah.
So yeah, it's definitely worth understanding the coal measures still.
Yeah. Okay, listen, Louis, I think we should give you a bit of a break now, and unless there are any other burning questions. I don't see any. Pause. No. Tom, would you like to do the vote of thanks? But firstly, thank you very much, Louis. I think that was great.
Pleasure.
I would. Thank you very much, Graham. Yes, Louis, thank you very much for getting our lecture series, our online lecture series, off to a cracking start there. And I'll tell you some things that obviously I learned during this, but also what I liked very much about this presentation tonight. It included some of my favorite things, which obviously is field work, which is very good, and also data. And putting those two things together, what I found interesting about your talk is the data, as you said, was all free, basically, available at EGS and other sources. And then you actually collected your own data, you know, the proportions of sand in the rocks throughout the region. And that was all to get a detailed picture, as we've just been discussing, for the geothermal regime of the area. Now, those two things, the field work and the data, are all things that anybody here tonight could also do. So everybody here has got the potential to investigate the geothermal regime. Everybody here has got the potential to be able to do this kind of work And I really, really encourage people to, you know, take up the role that Louis has shown us to sort of do, I wouldn't call it their own bit for understanding regional geology, but you know, to go out and do some geology, but also make use of these free resources as well. And yeah, having this tie in with COP26 is vitally important and really pushes home the importance of understanding regional geology and looking at regional geology with a new eye. And as ever, I always say that there's always so much more to be done. And that's because you can always look at a region in it with a new perspective. And you've really sort of brought that home tonight with the piece of work that you've done here. And for that, I commend you very much, and thank you on behalf of the Society this evening. Thank you, Louis.
Thank you.
And I'll end the recording there.